Today I'm happy to, we are happy to have two presentation from Dr. Jim Stallard and Dr. Usman Alim from University of Calgary. Dr. Jim Stallard is a professor hosted within the Department of the Mathematics and Statistics. He has served as an associate head of this department, transitioning to the co-director of the Data Science and Analytics program in 2018. He was the lead author of the first Canadian edition of introductory statistics, exploring the world through the data, and is a past recipient of the Faculty of Science Teaching Award. He has also served his professional society, the Statistical Society of Canada, president of the Statistical Education Section, and as a chair of the Statistics Education Committee, a committee on which he currently serves. And the next, another presenter is Dr. Usman Alim. He's an associate professor in Department of Computer Science at University of Calgary. He directs the visualization and graphics group that addresses a variety of problems in visual computing and using multidisciplinary approaches rooted in data visualization, computer graphics, image processing, scientific computing, high performance computing, data science and machine learning. He is also co-director of the Data Science and Analytics Professional Graduate Program. So now we are happy to listen to their presentations.
I'm going to walk around. Well, good afternoon, everybody. My name is Jim Stallard, so here's my partner in crime, Usman Alim. We're going to talk to you today a little bit about the data science program at the University of Calgary, the past, the present, and what's coming around the corner in the future. But first and foremost, this is, I would like to make a territorial acknowledgement. I do live and work on historical Aboriginal territories, so I'd acknowledge the Aboriginal or traditional territories of the Treaty 7 region in southern Alberta, Black Nation, which includes the Pisani, the Siksika and the Kainai First Nations, as well as the Tsuut'ina First Nation and the Stoney Nakoda First Nation, including the Chiniki, Bears Pond, Wellesley First Nations. Quite honestly, I should know this by heart by now. And the city of Calgary is also home to the Métis Nation of Alberta, Region 3. So, as I said, we're going to talk a little bit about a brief history of data science at the U of C. It's a relatively short history. Then we're going to talk about the current state of the data science program or programs at the University of Calgary, and then we're going to talk about what's coming around the corner at the University of Calgary in terms of data science, so in fall 2003 and beyond. So, way back in September 2016, there was a group of relatively motley crew of 4 people. So there's me, and there's my colleague, Dr. Joseph Ling, who's since now retired. I don't know if his retirement was a result of being on this committee or not. And then we have two colleagues from the Department of Computer Science, Wes Willett and Ehud Charlotte. And we were tasked to put together a data science program. So 2 people from the Department of Mathematics and Statistics, my home department, and 2 from Computer Science. And it took us quite a while. It took us a couple weeks just to define what data science was. So the discussions got relatively intense. There was no beard pulling or anything like that, but this is referenced in old Bugs Bunny cartoons. So there's Pumpkinhead and Kurt, and eventually we made amends and came to a definition, or what we thought a good definition of data science was. I'm sure if you talk to your colleagues, talk to 300 people, you're going to get 300 different definitions of what data science is. So this is what we came up with, and it's based on this definition that we built the various programs that exist at U of C. So we call it an amalgamation of applied branches of computer science and statistics. And again, data science, what is a data scientist? This is a question that perhaps doesn't have a correct answer, but I'm a statistician, and years ago when I would walk into a room and identify myself as a statistician, I could clear a room quicker than an anthrax game. Right? Or I get the, I took a statistics course at U of C, and you get the nightmare scenario. Now you walk into a room and you're a data scientist. I mean, it's like a Kardashian walking in. So you're the most popular person in the room. But I digress. Based on our definition of data science, we put together what was intended to be an undergraduate major, so a BSc with a major in data science. We did it relatively quickly. We had a quick meeting with the provost at the time. The provost is a very busy person. The provost is asked almost on a daily basis for money for new programs. So we had a 5-minute meeting with the provost, and it was very well received. So she gave us some money, and she said, well, instead of starting with the major, start with the minor. So she gave us some money to start the undergraduate minor. And with that money, we were allowed to convert some faculty, one in my department, one in computer science, to tenure track positions, which was good. So this minor program was approved in February 2016, and the undergraduate minor was to start in the fall of 2018. So in fall 2018, or looking ahead to fall 2018, we have an undergraduate minor in data science. Now, how this minor works, I won't get too much into the details, but a student in the minor can have a degree. They can be a student in the Haskell School of Business, so they can be a Bachelor of Commerce degree. They can be a Bachelor of Nursing degree if they wish. They can be in a kinesiology program, science program, engineering program. Engineering programs are pretty demanding in terms of the number of courses they have to take, so we don't have too many engineering students in the undergraduate minor. But they are required to complete 8 courses in the data science minor, and these are the courses that they're required to complete. So Data 201, which is Introduction to Data Science, and then a programming course, 2 courses in statistics. So they're seeing some introduction, they're seeing some RStudio, and they're seeing some classical inference, some simulation inference, and some machine learning. Then Data 301, or 471, and then there's a capstone project. The capstone project is a course I'm currently teaching, or co-teaching right now. So currently, the minor has been going for about 5 years, and we typically have, on average, about 80 students with a declared minor in data science. So after the data science minor, we thought about putting together a major in data science. But at the time, the higher-ups at the university thought maybe it would be more interesting seeing some of the trends that were going on, not only in the US, but seeing the professional program in data science at U of T and at UBC. So we thought we would try to compete. We thought we would compete with them. And we pivoted we put a stop to the creation of an undergraduate major in data science, and we moved on to the creation of a professional program, a master's program in data science and analytics. So here's what it looks like, or here's where we started. We created it as a stackable certificate or a tiered program, in the sense that a student entering the program could finish a certificate or complete a certificate, a graduate certificate in data science analytics. And there's 4 courses that populate the certificate in data science. Once they complete the certificate in the professional certificate in data science analytics, then they could springboard into any one of 3 diploma streams. So typically we offered the certificate piece in the fall term and the 3 diploma pieces, diploma in biostatistics, health data science and biostatistics, a diploma in core data science, and a diploma in business analytics. All 3 diplomas, they have different courses. They have the same learning outcomes, but we're providing students with domain expertise. So this is how we started the program, a stackable certificate diploma program. And we ran this version of the program. Our first intake was in fall 2018. Next slide, please, Usman. And so in fall 2018, so I should say that when we sent off this program to the Alberta government, we sent it off in early January, first week of January of 2018. We received approval very quickly, middle March of 2018. So you can imagine the marketing that was ready to go to accept students into the program for 4 or 5 months down the road. So we were quite pleased with our first intake. So we had 34 students, and again, this visualization is broken down by students in the various specializations. In the first year of this program, the reason why there's the HDSB, that's the Health Data Science and Biostatistics, the reason there was 0 is the Health Data Science and Biostatistics diploma is run by the Cummings School of Medicine, and they weren't ready to offer the courses just yet. The Business Analytics diploma, those courses are run by our friends over at the Haskins School of Business. So in fall 2018 and fall 2000, then it bumped up, it almost doubled in fall 2019. So during this time, we always envisioned this to be a master's program, so a course-based graduate degree, professional degree. So we started working on the master's piece of the program. Next slide, please, Susan. Oh, it's your turn. Oh, you want this?
I'll try to use this.
It's nice to walk around. It's a nice, cool room.
I'll use this. I have to point some things on the slides. Can people hear me? All right? Okay, sounds good. All right, so Usman Alim, I'm from the Department of Computer Science, and I share the pleasure of, I have the pleasure of sharing the co-directorship of the program with Jim Stallard. I've been doing this since about 2018, so just around this time when the certificate and diploma pieces were running. I joined the program, and one of the things that we did around that time, this was just before the pandemic, we organized a curriculum retreat for the instructors teaching in the program to see how well aligned we were with the learning outcomes and the knowledge areas that have been put forward by the Association for Computing Machinery in the data science space. So the ACM breaks the knowledge areas that are within data science into some sub-disciplines, subtopics, which you can see here on this slide. And what's really shown here is how well aligned our curriculum is with those knowledge areas. So here, this is a tree map showing what topics are covered. So the size of the tree map essentially is showing how much each of those topics is receiving coverage in the program. So as you can see, we have topics in machine learning, analysis and presentations, so that essentially covers your visualizations, interactions, dashboards, and then data acquisition, governance and management, of course basic computational skills, so programming, data management, and then also professional skills like communication and professionalism. And of course, and then one thing we did was we added some additional things that we have in the program, which distinguishes our program from other programs that are in Canada and in the US or worldwide, is that we have these domain specializations in the program that you see here in the middle. So currently we have the core data science stream, which does not specialize in a particular domain, but delves deeper into topics in data science, so in cloud computing or machine learning. But we do have these two specializations, of business analytics and health data science and biostatistics that you see over here. If you maybe want to, this might be a little bit more interesting to folks in the data science space, is kind of what kinds of tools that we're using. So this chart kind of highlights some differences between the different specializations. So on the left, you see the core data science specialization, and on the right, we have the domain specializations, business analytics, and the health data science and biostatistics. So there is quite a bit of overlap in these in terms of the tools. So all of them are using R and Python heavily. So a little bit more in the core data science stream, where there is more coverage of more usage of Python, and in the business analytics diploma, they're heavier users of R. And then you can see a bunch of tools there that are essentially different flavors of Python and R packages that are used for various data manipulation and wrangling, machine learning, and those types of tools. But also you will see some of these no-code kind of approaches, or kind of software tools, the complete suites of data analytics tools that some of these specializations are using. You see Power BI here, and somewhere around here there's also Tableau, like mentioned over there. So quite a bit of overlap, but we're covering the the open source ecosystem of data science quite well in these different diploma streams. This, I'm not sure if people in the back can see this really well or not, but this is an outcome of the topic mapping that we did. It's using, so in the center, you will see kind of, so it's highlighting how machine learning concepts are covered within the program. So you kind of see kind of mixed methods, unsupervised, supervised learning, deep learning, and then general methods. And then the green bubbles are there showcasing the different courses that we have in the different streams. So up here we have the health data science courses, down here we have the core data science courses, and over here we have the business analytics courses. So we see kind of they're approaching the various different topic areas within machine learning. Those are covered in all of the different specializations. So you will see that perhaps the numbers are showing up there or not, but the numbers indicate kind of at what level these concepts are covered. So 1 would be kind of introductory, 2 is intermediate, and 3 is advanced. So you will see here that in the business analytics, they're covering fewer topics, but they're covering them in more detail, whereas in the health data science and the core data science diploma streams, we're covering a variety of topics, but at an intermediate level. All right, you want to continue with this?
You're doing great.
Yeah.
All right. Yeah. The next one.
Okay. All right, so this is, that was the state just before the pandemic, and around that time, this is just around 3 years ago now, we were also putting together, you know, the kind of the feather on the cap, or the last piece of the master's program, which includes a capstone course, so which is this integrated topics in data science and analytics, and also an internship. So this is a professional program, so students need relevant industry experience. So when they complete the integrated topics course and engage in a 200-hour internship, they get their master's. So the certificate and diploma were already approved. We just had to go through another approval process before we could submit this to the government. And being an interdisciplinary program at the university, there were, I don't know, at least 10 different committees we had to go through to get this approved, because there are so many different departments and different faculties involved. So this is also something new for the university, is how to kind of navigate this real interdisciplinary space of data science. But after several months and countless meetings, it eventually got approved at the university levels. Then we submitted it to the government in mid-April 2019, and then we waited for quite some time.
Waited and waited and waited, bureaucracy, waited, which is interesting because they approved these the provincial government was, you know, they heard about the program, and they approved the certificate and the diploma really quickly, within 2.5 months, so we were very pleased. So we did not expect it to take, well, you can do the math, you know, we didn't expect it to take this long. Sorry, Usman.
Well, and then COVID happened, and that slowed things down even further. So eventually we got the approval in the middle of 2020. So at that time we also had students who were anxiously waiting for this the last piece so that they could come back and finish their degrees. So we had a backlog of students. They went through the program. You want to take over here, Jim?
Yeah. So one of the things that we communicate to the students in the program, even the first cohort, was we were very transparent to the students, saying, we know you're pursuing a certificate or perhaps one of the 3 diplomas, but there is a master's piece coming along. So at some point, you will be able to complete a master's degree in data science and analytics. So we kept them in the loop. We were, as I said, we were very transparent in terms of letting them know what the process was. And I know at some stages they were very frustrating. When's the master's starting? And we're waiting for the provincial government. Thank you for being so patient. So, as the slide you'll see in a few moments, so we did have this bottleneck of students. So we had a cohort that finished their diploma in April of 2019, and a cohort that finished their various diplomas in fall of 2020, and then we still had students coming in. So as you can see, once we had a sense of the master's was approved, and we started promoting the master's, so you can see we had quite a jump in the number of students. In fall 20, winter 21, so it's a little different in the sense that in winter 21, winter 22, winter 23, we typically have a fall intake of students, and we run them through the certificate in the fall, and then 1 of the 3 diplomas in the winter. But in winter 21, winter 22, and this past winter, winter 23, we did have a winter intake. We had a winter intake this year because we had some international students that could not get their visas in time. We had about approximately 15 to 20 of them. So we wanted to act on good faith, and so that's why we're running a winter, or started a winter cohort this winter. So you can see our numbers have consistently gone up. And one thing I do want to say is, with respect to the master's in data science and analytics, this is for essentially anybody. So I'm sure that there's many of you in this room, maybe 5 years ago, 10 years ago, you were doing something completely different, and then you either fell into the data science space, or something caught your eye and you're attracted to the data science space. We were finding initially that in our first couple cohorts, that many of the students we were seeing were students that were pivoting their careers. There was a subset of students who were tired of the cyclical nature of oil and gas. We've had students with PhDs in geophysics come through the program. We actually had a medical doctor. She came through the program to get a better sense of. She went through the business analytics piece, but to get a better sense of understanding data and being able to visualize data and tell stories with data. Next slide, please. So, with respect to the master's piece, there's two courses. There's what we call an integrated topics course, and the student has to finish the integrated topics course. Then they go on to either a professional internship or a research internship. So what is the integrated topics course? It's basically a residency course, a 2-week course, so each day 9 to 5. And we break it up into 10 modules. So each day is a module, and some days maybe module splits. And the idea behind this is there are some higher level technical data science-y aspects that we do want to present to the students that we just don't have time for in the program. Because keep in mind, I do want to communicate that each one of the courses that is taught in the program is approximately, if you remember back to your undergraduate days or your university days or your post-secondary education days, each one of those courses is probably 1 1/3 courses. So the syllabi are very, very busy. There's a lot of material we're teaching to these students in a very, very short time frame. So we can't teach it all. So as you can see, pardon me, this is an example of the first iteration of Data 691, which was run in the spring of 2021. So we were subjecting the students to the 3 technical topics you can see, but we also wanted to expose them more to the soft skills. So we've been
over the course of the creation of this integrated topics course, we were talking to potential employers, people who were looking at data science students, and some of the feedback we received was, well, we'd really like them to pick up some of these soft skills. So this is some of the communications that, for example, Canadian Border and Security was telling us about, Statistics Canada was telling us about. They've taken on some of our interns, as you'll see in a few moments. And just to give them a sense of maybe a bit of some of the flavor of a mini MBA. So there are some of the there are the professional topics that were excuse me, made up the modules in the first iteration of 691 in the spring of 2021. So once the student finishes the integrated topics course, then they go on to either a professional internship or a research internship. And what's the difference between the two? Professional internship, they get some money, they get paid. Research internship is unpaid. Either way, the expectations of the student are the same. The internship is 200 hours, so a minimum of 200 hours. Many of our students in the program are currently working or are working full-time and are taking the program full-time, which is very impressive. I don't have those time management skills, that's for sure. But we don't expect such students to tell their employer, sorry, Max, I've been working with you for 20 years, but I got to take a leave and find an internship with some other company. So we certainly don't expect that for people who fall within that cohort. So they can do an internship with their current employer. They just have to carve out some little specialized project, spend 200 hours on that project, and specifically they need to try to employ some of the data science methods that they've seen, not just in the diploma, but in the technical piece of Data 691, work on some project. So 200 hours, they give an oral report, a written report, and they've got a master's degree in data science and analytics in their back pocket. And the structure of the program is a one-year program. However, a student can finish it in 10 months. Okay? And we do understand that typically internships are 3 or 4 months, and they're relatively seasonal. We're just asking a student that if you've got a 3-month or 4-month internship, carve out 200 hours, devote that to your professional internship project, and you're good to go. Okay. So these are just again, I'm not gonna waste your time. Everybody here can read. So here is some of our past internship partners, and if you are an employer and you're scratching your head and you're thinking about maybe you need some internships, please talk to us after. Okay? We would love to talk to you. Okay? So there's some of our past people that have, or entities that have taken on our students as interns in the past, and and at the present, I should say. So now we're getting to the future part of the presentation. Looking ahead, so as I said at the start of the talk, fall 2023 and beyond. So we are adding another diploma specialization to the Masters of Data Science and Analytics program. This is a specialization in financial energy markets and data modeling. So essentially what happens is students in this program take 2 of the same courses as students in the core diploma program. So they take a course in some sampling theory, some nonlinear regression, some generalized linear models, and machine learning. And then they take 2 different courses. They're kind of tier courses in the sense of modeling the financial energy markets data, and we were very, very creative in this, advanced modeling of financial energy markets data. So we put a lot of thought into those course titles. Okay, so and then we hope by fall 2023, this fall, to have a full-blown undergraduate major in data science. So we've got the minor, we've got the professional program, and the major. So as Usman alluded to earlier, this is a very laborious process when you create a program.
especially the interdisciplinary aspect of this program. And the transdisciplinary aspect of this program, it has to go through many, many committees. So it's gone through the top. We're interested in the internship process. It's centralized, so if you send an email to science.internship@calgary.ca, you'll probably get Kristen, and she's fabulous. She knows internships in and out. So that's all we have to say, I think. Yeah.
Want a question? Are you interested in questions?
Absolutely. Yes, please. Yeah. So, yeah, go ahead.
I'm a data management guy, and I wonder why you don't teach data management until year 3, when I think it should be taught in high school. That's just my opinion.
Oh, you mean in the major? Yeah.
Major. Because getting your file names right is something you should be doing by the time you're 16. In my opinion.
No, that's fine. You know what? That's a computer science thing. So he's I'm the numbers nerd. I'm the stats guy. He's from computer science. So maybe I'm gonna guess. Maybe it has something to do with maybe the computer science wants to make sure that its students know how to program, et cetera. That would be my guess, but maybe Usman can.
Yeah.
How in depth does data governance and management go? There is a module, so in the masters or in the MDSA program, there is a module on data governance and management, and there's a bit of a module on data governance. I can't remember whether it's a half day or a full day. So those 2 screens or those 2 bubbles you saw, that was the first iteration. So my answer is 2 parts. One of the nice things about the integrated topics course, which is the first course the students take in the master's program, is every year we're looking at the modules. So for example, this year, some of the modules are being taken out, and we're replacing some modules with newer ideas, such as, I believe one of the new modules is code, no code. So I'm not sure which module that's replacing at this point. So that's the first point. The second point I wanted to get to was about the undergraduate major. It slipped my mind. We'll get back to you.
Maybe I'll come and talk. Yeah.
Oh, sorry. No, I remember now. Yeah, there is a course. There's lots going on in this small little brain. So we are creating a special course for ethics in the undergraduate major, and actually we're working with a faculty member over in the Department of Philosophy that talks a bit about a lot about ethics, data models or machine learning models that are already biased because they're trained on biased data. So there is a specific course. Yeah, I think it's a 400 level course. So 3rd year, 4th year in the undergraduate major that's specifically on this. So
This is all excellent to hear because some of us have been sort of looking at education, in the universities have been lacking, and it's people have gone and they come in as database analysts or they don't even see that. And recently I've been seeing master's courses of information management. I think great, we got business leaders going to be taught. They got to be interested and chase this. But where are we teaching the people to actually do information management?
And it is challenging at the university side. I mean, I wish we could just, if we wanted to change a course, we could just do that. But it starts with a proposal, and it starts with a meeting. You gotta meet this department and meet this department. But that's one of the great things about us being co-directors and having this integrated topics course is if we want to flip out modules, try new modules, as I said, the code, no code, we don't need to ask anybody's, we don't need to ask permission to do that. We just, if we get in trouble, we just say we're sorry. So, yeah.
So, I'll ask a question. Of these new courses that you guys have, they're brand new. Which of them do you think differentiates the University of Calgary the most? And maybe you guys should both answer because one is the stats guy, one is the health guy. You might disagree on that. Not loud enough.
I think what what will differentiate our undergraduate major from some of the other undergraduate majors is, I think there's, well, first of all, we have a full course, we are going to have a full course, as mentioned earlier, on ethics, data ethics, et cetera, and governance. So I think that's one distinction. I think another distinction is we are using some higher level math courses, so there is a course in optimization. And as I said earlier, a lot of the data science programs are just, in my opinion, are a mishmash of, well, let's take the courses we've already got, and let's change that to data science, or let's change some computational computer science course to data science, which is rebranded. So we are making a lot of efforts to design courses specifically for the data science students bed. So that's my take on it.
Yeah, so I'll just add to that. So I work in an area, I guess, in computational sciences, which requires a lot of training in mathematics. So what I see, I guess this is just echoing what Jim just said. So there is these higher level math courses which you will not see in other computer science or data science programs. Here, like for example, linear methods too, linear algebra and higher level linear algebra exposure. We don't have that in computer science programs. So students coming from the data science program, they will have those higher level mathematical and analytical skills. So optimization, I mean, we do that all the time in training machine learning models. It's it's behind the scenes. There's all of these excellent optimization routines that people have developed, mathematicians have developed in collaboration with computer scientists, because there's the mathematics side and then there's also the algorithmic side of it. So this is a course where it's covering both the math of optimization and as well as how you implement these, keeping in mind kind of the complexity and speed and performance considerations.
Yeah, and the mathematics that's necessary. We're not gonna have a data science major take a course in abstract algebra. So there's no rings and things that they're going to be exposed to.
So what are you doing to give your students a competitive advantage when it comes to actually working in data science roles and advanced analytics? Because we all know it's a lot different when you're switching from academia to working in the real world and the data sets and the messiness and dealing with business lines. So curious just in terms of what the preparation looks like around that.
Well, a couple comments on that. The courses that we instruct throughout the program, right now I'm talking about the MBSA program. The courses are heavily they're intensive in terms of assignments and group work. So there's no 3-hour final exam or anything like that. So we are getting them. They are diving quickly into working in teams. Outside of that, there are aspects of the program where we're trying to assist the students through networking, developing some of their networking skills. We have what's called a Data Science Friday once a month, where we get people from the industry to come and talk to our students. And if you want to think about potentially doing a Data Science Friday at some point, contact me. We're pretty much done those events. There's one more event in April, but we're pretty much done those events. But that's what I would say right now. Just trying to create various aspects to assist the students, and so they can show off what they're able to do. For example, a poster session. I'm probably missing something.
No, I was just gonna pitch the poster session again, because what we do is we get students exposed to real-world data sets from the very first course. So it's not like toy data sets that they're working with. They will go out to like data portals, open data portals, and work with data sets there, which can be sometimes clean, sometimes very messy, but it's kind of, they get the real experience of what it'll be like working with these data sets. And yeah, if you want to take a look again, I would advertise the poster presentation that will happen in about an hour, 3 p.m., where you can get to see what give you a flavor of some of the projects that students are engaged in the MBSA program.